Hi, welcome to Dr. Raz the Baking Chemist. So today's topic is all about bond enthalpies. It's part of the energetics topic. It's a year one topic, but also obviously year twos will need it as well. It's a request from one of the students. Okay, so let's see what we can do. So it says some enthalpy data are given in table 3. So this is the enthalpy data. So that's the formation of ammonia. So my thinking is okay. So they're giving you a full equation. Exothermic, enthalpy data. Okay, so this is atomization. So nitrogen is breaking down into nitrogen atoms. All right, and the hydrogen is okay. Fine. Let's move on. Use the data from table 3 to calculate the bond enthalpy for the nitrogen hydrogen in ammonia. Okay, so they want you to work out a single bond enthalpy for a single bond, nitrogen hydrogen bond. Now, there are two ways you can approach it. I hope you know that there are sort of 3 thermochemical cycles that you're probably going to cover, or you have covered already in year 1. One of them is when you're given the data of enthalpy of combustion, what kind of cycle do you need? The other one is when you're given the data of enthalpy of formation, what cycle do you need? And the third one, of course, is the bond enthalpy, what cycle do you need? You can use a cycle, or you can use a formula. Okay, so let me show you what I mean. So by the cycle. So the cycle is, let's start with a cycle. So the cycle, in a thermochemical cycle, the main reaction, I always try and draw horizontal. So the main reaction, of course, is that. That's a gas, and that's a gas, and of course it's balanced. Right, now this is a bond enthalpy, so that means what you need to do is you need to have the third sort of corner of this cycle as atoms, because remember, when you're atomizing, right, bonds, you end up with atoms. So here I'm going to have nitrogen atom. I'm going to have hydrogen atoms. Of course, they're going to be gases. And of course, when you atomize that, they'll give you the same thing. But of course, I'm going to balance it. So 2 nitrogen atoms broken down gives you, a nitrogen molecule broken down gives you 2 nitrogen atoms. And 3 hydrogen molecules broken down gives you 3 times 2 is 6. And you know what? I'm just going to write it down here again, just to try and make it a little bit neater with gaps. And 6 hydrogen atoms, because 3 molecules of hydrogen broken down to give you 6. And of course, if this is balanced, then these should be balanced from that side as well. 2 nitrogen atoms, and 3 times 2 is 6 hydrogens. Okay, and of course you're atomizing it. So I'm going to draw my arrow going that way and going that way. Okay, so that's the cycles you can use, or you can use a formula, which I'll tell you in a second as well. All right, so what they've given you, so what information have they given you actually? So that's atomization as well, isn't it? That way. So of course they're going to give you hydrogens. You don't have to have the arrows exactly the right place. It's not a problem, as long as they're generally going down. So you can use this cycle, okay, or you can use a formula. Okay, so let me give you the formula. So you can use this cycle, or you can use the formula. So the formula is very simple, and I'm going to write it down here. I hope I've got enough space. Is enthalpy of a reaction, which is that, of course, is equal to, and that's not K, that's an R, is equal to sum of the enthalpy changes for the bonds broken minus sum of the enthalpies of the bonds formed. So you can use this formula, or you can use the cycle. I'm going to tell you to be careful when you're, using the formula. Often, people write, students write this: broken minus formed, or something like that. They use their own symbols. Now, this means nothing to the examiner, and if your final answer is wrong, you're not likely to get any marks for that. However, if your final answer is wrong, and you've written this down, you will get a mark for this, yeah? Or if you've drawn a cycle, you'll get a mark for a correct cycle, okay? So if you are going to use a formula, please use a full formula. Yeah, it takes extra couple of seconds, but please do it, just in case you make a silly mistake and you get your answer wrong. All right, let's do this. I like using cycles, but let's use this. Okay, so the data they've given you is atomization of nitrogen. So that's that. And they say that's +94. And of course, kilojoules per mole. The hydrogen atomization they've given you is +436. Okay, now I'm immediately going to be aware that there's 3 moles of hydrogen. This is per mole, so I'm going to have to multiply that by 3. And the ammonia atomization, they've not given it to you. Okay, but remember, when you atomize ammonia, how many bonds are you actually breaking? You're breaking, think about it, you've got here, you've got 1 ammonia molecule has 3 nitrogen hydrogen bonds. So here there's not 1 ammonia molecule, but there's 2 of them, so you've got 6 NH bonds here. So you might as well put 6 NH bonds that you're breaking, isn't it, going from there to there. Okay, and of course the third information you've been given is that one, so formation of ammonia, so 92, so minus 92. Now, if you're a year 2 student watching this, I've explained to you Born-Haber cycles and how you can go back, and if you are a year 2 and you're not seeing it, you know, I'll put the Born-Haber cycle video up here somewhere, have a look at it. But what you're doing is you're doing from here, so you're going to go from here to here. All right, that's what you're trying to find out. But you can't go from there to there, right? Why? Because the road is blocked. Yeah, in other words, you're trying to find that out. So what you're going to do is you're going to go around that area. So you're going to add up all of these things around that area. So literally, you're going to add up all of those things area with one exception. Anytime you go against the arrow, you're going to change the sign. All right, so let's try and do that. Okay, so I think I've got enough space. If I can move that up, possibly. Okay, so I'm going to go back. Remember, I'm going from there to there, and I'm adding everything, yeah, from here. So I'm going to go from here to here, that way around, and I'm going to add everything together. And all I'm going to do is, if I'm going against the arrow, I'm going to change the sign. If I'm going with the arrow, I'm going to keep the sign the same. So I'm going against the arrow there, so I'm going to change the sign. So that would be 92. Plus, I'm going with the arrow, so that's going to be sign remaining as it is, plus 944. Plus, now obviously I need to multiply that out, and so if I do that now, 1308. Okay, that's plus 1308. Why? Because I've not changed the sign, because I'm going with the arrow. Okay, so 1308, and that must equal what? That must equal 6 nitrogen hydrogen bonds. And so literally you work this out, and then so that is 2, 3, 4, 4, and that is 6 NH bonds, but you only want 1 because that's what the question is asking you, 1 NH1. So simple matter, doesn't take a genius to figure out what you need to do. Move the 6 around, and that divided by 6, which equals 390.6, so that's a nitrogen hydrogen bond, and that equals 390.6. okay, I might as well do it here, kilojoules per mole, and that is nitrogen hydrogen bond. Okay, so that, now the question is, do you leave it as 390.6, so 4 sig fig, or do you give it 3 sig fig? Well, all of these things are given in sort of the highest precision is 3 sig fig, so you know I can leave it 3 sig fig. So this is the smallest one, so you can leave it as 2 sig fig. So I suppose 2 sig fig, or or greater, yeah. So I suppose you can leave it as 2 sig fig, but nothing less than 2 sig fig. So I can leave it as 391 kilojoules per mole. Right, I'm going to leave it as 3 sig fig because that makes sense with my answer. Okay, but minimum is 2 sig fig, 390. Okay, so that's 3 sig fig. Now you could have done this using the formula. So how would you do it? In effect, the method I follow visually is the same as the formula, but it's just that this is visual and this is formula. You've got to remember the formula. Bonds broken, adding them all up. So which bonds are broken? All of these bonds are broken. So in effect, what you're going to be doing is you're going to be adding that, because these are all the bonds broken. So you'll be saying 944 plus, 3 times 436 is 1308, and minus bonds formed. And of course, how many bonds are being formed? Yeah, it's 6 NH. So you're going to just put 6 NH here. And if you think about it, and of course, the enthalpy of reaction is minus 92. So literally, that is the same as that. It's just that this I've done using the visual method, and this I've done using the bonds broken. But if you think about it, that's exactly the same equation. Okay, so yeah, if you are, so all I'm going to tell you is that if you are, for example, using the formula, please don't write that, because if you make a silly mistake in the calculation and you get the wrong answer, yeah, some weird answer, then you won't get any marks. Usually the marks are for, either the cycle, the correct cycle, or the equation. So that's 1 mark, and the second mark is for actually slotting in. So the second mark is for actually slotting in the values. Yeah, so that's going to be a second mark, or in your case, in the formula case, it'll be, that's the second mark, and third mark is for the actual answer to 2 significant figures. And by the way, why did I say significant figures, 2 or more, or 3? Yeah, again, I've got another video, I'll put it up again to have a look. Yes, have a look at those significant figures. They're important, that you don't put the wrong significant figures in, otherwise you can lose marks. And the third mark here, as I was saying, was when you actually work it out. Yeah, so it'll be exactly the same, isn't it? Put more. Okay, and that is, yeah, answer for third mark. Okay, so it was a quick question. As I say, you just got to be careful here that you don't just add them together, yeah, work this out and leave that as your answer, because that is how much energy is taken to break 6 nitrogen-hydrogen bonds, not 1. And they're asking you for one enthalpy for 1. All right, well, that was a quick question today. It's only a sort of a 3 marker, but yeah, students do lose marks just because they're not careful. All right, subscribe, like this video, share, and leave a comment below. Yeah, if there is anything else I can do. There is another question that that's been requested, and I'll do that next Wednesday. But keep them coming. Yeah, if there is a question that you want me to go over, if there's something that you don't understand on this, yeah, please let me know. Okay, or if I've done something wrong, if there's a better way of doing it, let me know. By the way, I hope this was clear that you didn't need to use both methods, use either that or that. I'm just saying. I'll see you next Wednesday. Bye.